So we'll be talking about chemical formulas and nomenclature. Chemical formulas are just the way that the chemical compounds are made up. Something such as H2O would be a chemical formula. Nomenclature just is the scientific name for the naming system that we're going to use. The reason that we have a specific naming system is that in the old days, before the 1700s, people would use traditional names. They didn't understand that we had atoms and molecules. They just understood what they could see with their eyes. So things such as water, sugar, ammonia, bluestone. Those were names for things that we see and we use on a relatively daily basis. Since that time, we've come to know that there are millions upon millions of chemical compounds. Using a special traditional name for each one would be nearly impossible to remember what the chemical formula was. So we came up with a naming system to make it easy to determine exactly what atoms make up the compound. We have two different classes of compounds, though, and each one has a slightly different naming system. To start with, we'll look at covalent compounds. Covalent compounds are formed when we have two non-metals. Now, if we look at the periodic table, I've given you a color-coded one here. Two non-metals are anything that's yellow, hydrogen included sometimes, as well as any of these elements on the right side of what I like to call the staircase. There are very few elements that are non-metals, but because of the nature of their configurations, we can actually make a lot of different compounds from non-metals with the same elements. We won't go into the details of that in Physical Science 20. That's left for Chemistry 30, and we do go into a detailed study of why we can have multiple configurations there. So if we take a look at nitrogen and oxygen, we can form N2O, NO, NO2, N2O4, all different configurations of those two elements, which each one having different properties. NO2 is deadly. You do not want to inhale that. N2O, that's laughing gas, used at the dentist, used in places like that, used as an anesthetic. So the same elements making up the compound, but having very different effects and being very different. So what do we do in order to differentiate between the different forms of nitrogen and oxygen? Well, we have to come up with prefixes to tell us how many of each type of element are present. And they're based off of the Greek prefixes, which you can see in this table here. So mono or mon, depending on what the starting letter of the element is, means we would have one of those. Di for two, tri for three, and so on, as you can see. So N2O4, we would call dinitrogen tetraoxide. 2 nitrogens, 4 oxygens. If we have CF4, for example, we would not call that monocarbon tetrafluoride. The mono is reserved for the second element alone. So this very easily lets us go back and forth between the name and the chemical formula. One last thing when naming, we always change the ending of the second element to IDE. So that's why we have fluoride and oxide here. That's just the tradition for doing that. So going between name and formula, if I give you in example 1 a P2O5, that means this compound is made of 2 phosphoruses and 5 oxygens, so we would name it as diphosphorus pentaoxide. Likewise with H2O, we have 2 hydrogens, 1 oxygen. This is commonly known as water, and most of us know that. But the formula name would be dihydrogen monoxide. We wouldn't say monooxide. Putting 2 O's together just doesn't sound right. So this is a case where we use monoxide. And again, we change the last letters of the element to IDE. NO2, One nitrogen, two oxygens. We would not use mono nitrogen just because the mono would apply to the first element, and we never do that. This would just be simply nitrogen dioxide, since we have two oxygens. Going backwards now from the name into the formula, we have carbon dioxide. Since we have no mono, that tells us we have a single carbon. Dioxide tells us that we have two oxygens, so CO2. Tetraphosphorus decafluoride, the tetra tells us we have 4 phosphoruses, so P4. Decafluoride, deca is for 10, so F10. And the last one, sulfur trioxide. Again, no prefix on sulfur. It tells us we have one of them, so we have S. Trioxide tells us we have 3 oxygens, so SO3.